In this lesson, we will learn about earned value management, an interesting and important topic that every project manager should be familiar with. We also have a few example problems at the end of the lesson. Let's get started. We will consider a project that will last for just 3 days. It is a software development project with a project plan based on lines of code. At the end of day 1, we should be ready with 100 lines of code, 200 lines of code at the end of day 2, and finally 300 lines of code at the end of day 3. The cost is $1 for each line of code. So the planned cost is end of day 1. The engineers could manage just 50 lines of code and $150 are spent. The project is clearly in bad shape. What actions do we need to take to bring the project back on track? Earned value management, or the EVM, is a systematic approach to analyze the project status with respect to planned scope, planned schedule, and planned cost. The keyword is value. Let's try to understand this term. The plan is to spend $100 for 100 lines of code on the first day of the project. We can also say that the value of 100 lines of code is $100. This is the value with respect to the planned cost, or the authorized budget. The value in earned value management is based purely on the cost. Let me introduce the term planned value here. Planned value is equivalent to planned cost. $100 spent on 100 lines of code is the value of 100 lines of code. Let me capture this information in a plot. This is a plot of planned value against the time. Next, the plot for actual cost. It is $150 at the end of day 1. The planned value at the end of day 1 is $100. Earned value is the term that is used to capture the actual value. The actual lines of code is just 50. 100 lines of code are worth $100. So 50 lines of code should be worth $50. Earned value at the end of day 1 is just $50. Here is a plot of earned value. We have learned the basics. Let us systematically analyze the project status at the end of day 1. We have accomplished activities worth $50, the earned value. The actual cost is $150. The gap between earned value and actual cost is the cost variance. Mathematically, cost variance is earned value minus the actual cost. 50 minus 150 or minus $100. Minus is bad and indicates a cost overrun. Next, let's look at the schedule. We were supposed to complete $100 worth of activities at the end of day 1. The planned value was $100. But in reality, we could only complete $50 worth of activities. The earned value is only $50. We are behind schedule. The gap between earned value and planned value is the schedule variance. It is simply earned value minus planned value. 50 minus 100 is minus $50, the schedule variance. Again, negative is bad and indicates that we are behind schedule. We are simply representing the dollar value of the delay. Time is money. There is nothing wrong in presenting time in terms of dollars. For this software development project, we have a cost overrun of $100 and we are behind schedule by $50. Quite informative. Let's move ahead and look at some additional parameters. To understand these new parameters, we will continue with the plot of planned value, earned value, and actual cost. Cost Performance Index, or CPI, is the first one. CPI is the ratio of earned value to actual cost. For this example, the CPI is approximately 0.33. The next parameter is Schedule Performance Index. Schedule Performance Index is the ratio of earned value to planned value. So the SPI is 0.5. We know the formulas for CPI and SPI, but we still don't know how to interpret these parameters. We will start with CPI, and we will consider three cases: CPI less than 1, equal to 1, and greater than 1. When CPI is less than 1, it means earned value is less than the actual cost. Cost variance is negative. We have a cost overrun. When CPI is equal to 1, earned value equals actual cost. Cost variance is 0. We are at par. The value of completed work is precisely matching the cost incurred for getting the work done. When CPI is greater than 1, cost variance is positive. We have a cost underrun. The value of work completed is more than the cost of doing that work. The project is progressing well. To explain further, EV is the value of work done. AC is the cost of doing that work. So, qualitatively, CPI is simply the value of work done for every dollar spent. In our example, CPI is 0.33. It is less than 1. We have a cost overrun. We are approximately 67% over the budget. We can also say that from the start of the project to the end of day 1, we have done only $0.33 worth of work for every dollar spent. Let us look at these three cases for SPI also. When SPI is less than 1, it means earned value is less than the planned value. This will make schedule variance negative. We are behind schedule. SPI is equal to 1 when earned value is equal to planned value. Schedule variance will be 0. We are at par, exactly on schedule. Finally, when SPI is greater than 1, earned value is more than the planned value. Schedule variance is positive. And we are ahead of schedule. EV is the value of work done. PV is the planned value of work. So, SPI is simply the value of work done against the planned value of work. In our example, SPI is 0.5, less than 1. We are 50% behind schedule. From the start of the project to the end of day 1, only 50% of the planned work is completed. To summarize, cost variance and schedule variance indicate the gaps in dollar terms. But CPI and SPI capture the gap in relative terms as percent. Let's move ahead and learn some more terms associated with earned value management. We will continue with our example and the plot. The first term is Performance Measurement Baseline, or PMB. The complete planned value plot from the start of the project till the end of the project, or the planned value curve in totality, is called Performance Measurement Baseline. This curve is the reference or the benchmark against which we evaluate the cost and schedule performance of the project at a given point of time. If the project progresses exactly as per the plan, the earned value and actual cost curves will overlap the performance measurement baseline or the planned value curve. We monitor the deviation from the PMB to evaluate the project performance. Next, we have budget at completion, or BAC. BAC is the total planned cost. It includes contingencies. In our example, as per the plan, the project should have a value of $300 at the end of the project. We are expected to spend $300. $300 is the budget at completion for this project. The project at the end of day 1 has serious schedule and cost deviations. The project manager might revisit his plan, re-estimate for the pending work and realize that the total actual cost at the end of project might reach $350, more than the budget at completion. This estimate of $350 is called the estimate at completion, or EAC. Remember that this is the estimate at the end of day 1 and might change in the future. Estimate at completion is the estimated total project cost at a given point of time. It is end of day 1 and we have already spent $150, the actual cost. Estimate at completion is $350. The gap between these two is estimate to completion, or ETC. ETC is the additional budget required to meet the project objectives at a given point of time, end of day 1 in our example. Mathematically, estimate to completion is simply estimate at completion minus actual cost. For our project, ETC at the end of day 1 is $350 minus $150, or $200. Finally, variance at completion, or VAC. It is the gap between planned project cost and the estimated project cost at a given point of time. Planned project cost is budget at completion, and the estimate is estimate at completion. So, variance at completion is simply BAC minus EAC. For this example, variance at completion at the end of day 1 is $300 minus $350, or minus $50. Minus is not good. This indicates that we expect the actual project cost to be more than the planned cost. Next, we will learn how to systematically find the value of EAC, estimate at completion, and ETC, estimate to completion. Before we get into the details, we must understand that predictions are almost never 100% accurate. Slight differences in assumption or approach can lead to different estimates. It is actually good to evaluate a project from multiple perspectives and come up with a range of estimates. We shall consider multiple scenarios and find EAC for each scenario. Let's start with the first scenario. We will continue with our example. At the end of day 1, our actual cost is $150. Earned value is $50 against the planned value of $100. AC1 means actual cost from start of project till the end of day 1. It is the cumulative cost till the end of day 1. Similarly, PV1 is the cumulative planned value and EV1 is the cumulative earned value at the end of day 1. We decide to discard the original estimates and re-estimate for the remaining scope. So, estimated completion at the end of day 1 will be actual cost at the end of day 1 plus the re-estimate of the remaining work. Re-estimate is actually the estimate to completion. Actual cost at the end of day 1 is $150. The project manager re-estimates the cost for the remaining work as $260. And we have $410, estimate at completion at the end of day 1. In general, for scenario 1, estimate at completion at time t is actual cost at time t plus the re-estimate at time t. Bottom-up estimation technique is relatively accurate and is often deployed while re-estimating. It is common to use the term bottom-up ETC for the re-estimates. Going back to the example, let's calculate the variance at completion. Variance at completion at the end of day 1 is simply the difference of BAC and EAC. BAC is $300, EAC is $410. So VAC at the end of day 1 is minus $110. Estimate to completion at the end of day 1 is EAC minus the actual cost. $410 minus $150. The ETC is $260. $260 is the re-estimated cost of the pending work. Let's look at another scenario now. Scenario 2. In this scenario, even though we acknowledge that the current cost performance is not as per the plan, we are confident that the remaining work can be done as per the planned cost. Here, estimate at completion is the money already spent or the actual cost, plus the cost of remaining work at budgeted rate as per the plan. We have completed activities that are worth the current earned value. The project goal is to complete activities that are worth VAC. So, the pending work is VAC minus EV. How can we find the cost of this remaining work? For our example, the planned value at the end of day 1 is $100. If the project progresses as per the plan, this means zero schedule variance and zero cost variance. Both the earned value and the actual cost will equal the planned value of $100 at the end of day 1. We complete $100 worth of work at a cost of $100. To complete our remaining work of BAC minus EV, the cost as per the plan will also be BAC minus EV dollars. This is the formula for scenario 2. In our example, estimate at completion at the end of day 1 will be actual cost at the end of day 1, $150. BAC is $300. Earned value at the end of day 1 is $50. So, the estimate is $400. Variation at completion at the end of day 1 is minus $100. Estimate to complete at the end of day 1 is $250. This is the cost of remaining work, the pending work at the end of day 1. BAC minus earned value at the end of day 1 will also give us $250. After day 1, in scenario 2, we expect the project to progress as per the plan. Both AC and the EV curves will have the same slope as the planned value curve till the end of the project. The gap between AC and EV at the end of day 1 is $100. The gap at the end of project will also be $100. BAC plus this gap gives estimate at completion of $400. We will now move to the next scenario. Scenario 3. Sometimes we see no possibility of the project progressing as per the planned value curve. We expect the remaining project to perform at the same level as it has been doing till now. The actual project performance becomes the basis of the estimation. EAC is the actual cost plus the cost of remaining work at current cost performance. To find the cost, let's have another look at the CPI. CPI is the value of work done per dollar spent. This means that the cost of work done should be our remaining work is BAC minus earned value. So, the cost to perform this work will be, solving further, EAC is BAC divided by CPI. BAC represents 100% scope of the project and is done at the current cost performance rate or the CPI. For our project, EAC at the end of day 1 is $900. ETC at the end of day 1 is $750. This value is equivalent to the cost of remaining work. The current variance at completion is minus $600. Going back to the plot, both AC and EV will extend with no change in the slope. The CPI will be constant. At the end of the project, AC will reach $900, the estimate at completion, and EV will reach BAC $300. There is another variation of this scenario. Scenario 4. In this scenario, the cost of remaining work is estimated based on not just the current cost performance, but also on the current schedule performance. The formula is I must mention that this is not a mathematically precise formula. The SPI has nothing to do with the cost. It is the work done relative to the planned scope, not related to cost. In real world, delay in schedule can potentially increase the cost. The usage of SPI in this formula is an effort to somehow roughly capture this impact. Using the formula, the estimate at completion for our example project is $1,650. Variation at completion is minus $1,350. Finally, the estimate to completion is $1,500. This value is the cost of remaining work, the second term in the formula for EAC. Occasionally, weights are assigned to CPI and SPI in the formula for estimate at completion. For example, if CPI has a weight of 80% and SPI has a weight of 20%, estimate at completion is again, this is imprecise mathematical modeling, very rough. Use this with caution in the real world. We have covered all the scenarios. Let me introduce you to a new term, to complete performance index, or TCPI. It is the cost performance needed to ensure that we complete the project precisely at BAC, the total planned cost of the project. We have to complete the remaining work with the remaining budget. Mathematically, TCPI is simply remaining work divided by remaining budget. BAC minus EV is the remaining work. AC is the dollars already spent. Total budget is BAC. Therefore, the remaining budget is BAC minus AC. This is the cost performance needed for the remaining activities to meet the project budget, or BAC. Going back to our example, BAC is $300. At the end of day 1, earned value is $50. Actual cost is $150. Therefore, TCPI will be approximately 1.67. This means that going ahead, for every dollar spent, $1.67 worth of work has to be accomplished. Occasionally, the project manager might conclude that the performance target set by TCPI is impossible to meet. The project manager, after agreement with all stakeholders, can change the cost target from BAC to EAC. Instead of trying to meet the original cost goal of BAC, the project manager has set EAC as the new cost target. Returning to our example, the project manager decides to use the EAC from scenario 3 for the TCPI calculations. EAC is $900. So TCPI based on EAC will be approximately 0.33. This is a much easier performance target compared to BAC based target of 1.67. Next, we will look at a few problems. You are the project manager for a construction project. The project will last for 12 months. At the end of third month, you evaluate the project performance. The SPI is 0.9, CPI is 0.85, and the earned value is $80,000. Which of the following is true about this project? A. The project is under budget and ahead of schedule. B. The project is under budget and behind schedule. C. The project is ahead of schedule and over budget. D. The actual cost is more than $80,000. Please pause the video and try the problem. The first two options claim that the project is under budget, and the third option tells us that the project is over budget. CPI indicates the cost performance of a project. CPI is 0.85. The value is less than 1. Not good. The project is consuming more dollars than what we planned. It is over budget. Clearly, options A and B are incorrect. Option C claims that the project is ahead of schedule, but the SPI is 0.9, less than 1. The project is actually behind schedule. C is also incorrect. We are left with D. D must be the correct choice. Still, let's understand why D is correct. CPI is the ratio of earned value to actual cost. CPI is 0.85. EV is 80,000. So AC is $80,000 divided by 0.85. We can see that actual cost will be more than $80,000. Dividing 80,000 with a positive number less than 1 will give us a result that is more than 80,000. Actually, we could have reached this conclusion without doing any math. We know that the CPI is less than 1. We are over budget. The actual cost has to be more than the earned value of $80,000. D is the answer. A project that will last for 2 years has an assigned budget of $1.8 million. At the end of 6th month, the project manager presents the following information. Planned value $600K. Earned value $585K. Actual cost $650K. The project manager also believes that the project cost performance is unlikely to change till the end of the project. Which of the following is true? A. The project manager will present $1.8 million as the estimated total project cost. B. As CPI and SPI values are not available, it is impossible to calculate the project cost estimate. C. The project manager estimates the total project cost to be $2 million. D. The estimate at completion for the project is $1,865K. Please pause this video and try to solve the problem. Alright, let's try to find the correct choice. Among the 4 options, B clearly stands out. It claims that CPI and SPI are not available. This is incorrect. PV, EV, and AC are given. We can easily calculate CPI and SPI. B is incorrect. A, C, and D. These options might sound different, but they are all talking about EAC, estimate at completion. For A, EAC is $1.8 million. It is $2 million for C and $1,865K for D. The budget for the project is $1.8 million. This is the total value of work that we have to accomplish in this project. Budget at completion. Earned value is less than the actual cost. The value of work done is less than the money spent to get the job done. We are over budget. Project cost performance will not change. This means we will continue to perform at the current cost efficiency level. The CPI is 0.9. The project has progressed with this CPI till now and will continue to do so till the project ends. In other words, the complete project from start to end will be based on this CPI. Estimate at completion will be simply VAC is the project scope. So EAC is $2 million. A and D are incorrect. C is the correct choice.